Okay, so let's take up these examples. So what would be my answer for the first one? I have x cubed times x to the power of 8. So I'm adding, you don't have to show me the step, I'm just showing you the step because I know you, like, sometimes it's nice to see it, to understand what's going on. Okay? How about for b, what do? I have x squared to the power of 4. I multiply the exponent. So I leave my base and I multiply my exponent, so that's going to be x to the power of 8. Okay, how about for c? So I subtract the exponent. All right, how about the next one?
So x something is
Okay, so you're taking, you see how it's all multiplication, right? If there's bracket, that means it's multiplication. So remember that you have to have the same base in order for you to be able to add the exponent. So out of this, I have x cubed and I have x. What's the power for this x? 1. So what do I do with these ones?
x plus 3 plus
So you leave the x and you add your exponent. So that's 4. And how about for the y? You see how I have y squared and y to the power of 5. So that is 7. So you see that I'm taking the terms with the same denominator, with the same base, and I'm adding their exponent because it's a multiplication. Do we get that? So anytime you see brackets, if there's no sign, nothing else, that's multiplication. Okay? How can you simplify the next one?
x
Yeah.
base and 4 plus 6.
Okay, so I have x to the power of 4 times x to the power of 6. So I'm going to keep the base. And what do I do with the exponent?
Add that.
Add the exponent to give you 10.
So x is
And then how about y? Y to the power of 3 doesn't change, right? Because there's no other y's in the equation. Okay, how about f?
right back down there. We're probably to the coefficient.
The coefficient is going to stay. There's no coefficient here, right? So that's going to stay as 2. Okay. Then you're going to take the x's,
Add them.
add the x's. Is that right?
Yes.
Is that right?
You subtract the x.
What do you do?
To the exponent.
What do you do with the exponent?
Subtract them? We are dividing it, so yes, subtract.
Yes.
We don't add, we subtract,
Subtract
right?
and
Yeah, yeah. Because you have division, right? You see how you have a division here? So you're going to take the x to the power of 7 and then you're going to divide it by x to the power of 6. So that gives you just x to the power of 1. Okay? How about the y?
Subtract 4 minus 6.
4 minus what?
6
4 minus what?
minus
1. Because the exponent for the y is 1. 4 minus 1 is
1. Oh, you get 1 miss.
3. How do I get 1?
Oh.
How do you get 6? That's the question.
Miss, yes.
Okay? Yeah.
Do I have to put the 1 beside the x?
You don't. It could be 2x y cubed. You can write it like this. Technically speaking, this is how you're supposed to write it with no 1. I'm just showing you so you guys like, this is the right way to write it. Okay? Do we see that? Do we understand that?
Yes.
Okay, so you're asking yourself, am I multiplying or am I dividing? And then if you're multiplying, you're adding the exponent. If you're dividing, you're subtracting the exponent.
Will there ever be like multiplication and division in
Yeah.
the same question?
Yeah.
Oh, great.
There'll be multiplication, division,
Oh, no.
everything. Want I give you one? Here.
There's no test for this?
Yes, there is.
So what is it? Say 5.
today, I don't know, every day. Why?
This one is
It's fun.
Yeah, fun.
Okay, I've got this. Come on, bring it, Maya, bring it.
Here we go.
Let's
That's one. Take it.
Can we get bonus marks for this?
Can this be my exam?
And trust me, this is not how the most complicated.
This is so complicated.
you can subtract it from the x to that one.
I wouldn't cancel until I solve the top.
If the letters different, but they're both kind of the same,
It can be, it's either different or the same.
so they're different, so I subtract.
You can't. You can't do subtraction or addition unless you have the same base.
Okay, so you multiply?
So tell me what you guys would do. What would you want to do?
I'd simplify the top first.
Simplify the top first.
Yeah.
Okay, so how would you simplify the top?
Start with
Start with the y.
the y.
Sure. So you want to do the y's. What do I do with the y's?
You add the exponent.
So I leave the y and then I add the exponent, right? So that's 4 plus 2 is 6. Okay.
Same with the x. So
Same with
x.
Same with the x. So what do I do?
So x plus to the exponent of 5 over.
Okay, and then how about the bottom? What do you want to do with the bottom?
You want to open the bracket. So you want to get rid of the. So it's power to power.
So I have a power to the power here. So what do I do with
Yeah,
that?
So you multiply them.
Multiply. So that's x to the power of 4
Yeah.
and then y.
Y.
Okay.
Okay, so then y has an invisible 1. So then
Yeah.
if you're doing division, so it's 6 minus 1. So
6 minus.
Yeah. So that's going to
y
be
to the power of 5. And
Okay.
then x.
done.
Done.
It's done. It's not that bad. Come on. You want me to give you another one?
No.
That's bad.
With an end quadratic.
No.
Yeah, go. Do it. Let's.
No, I have to teach you a little bit more before I can give you the even more complicated. Okay? Are we okay with this?
Is it wrong if I flip the x and y?
If you write x, y, 5? Nope, it's right. You're good with that. Okay? When it comes to multiplication, it doesn't matter if you multiply 6 by 2 or 2 by 6. It's the same thing. All right. So, moving on to what we call the distributive property. If I must say, this might be one of the more complicated ones. Okay? So, if you have multiplication, so you see how inside that bracket here, I have x to the power of 4 times y to the power of 3, and then I have to the power of 2. Okay? Now, can I simplify inside the bracket? No, because they don't have the same base, right? So, but I have that power of 2 that I can actually distribute. Okay? So, because it's a multiplication here, I can actually distribute that power to the power to each term inside the bracket. Okay? So, the rule with the power to the power, what do I do with the exponent?
Multiply.
Multiply. So that would be x to the power of
8,
8, y to the power of
6.
6. Okay? So I simplified, right, by bringing in, right, that exponent. So that distributive property, I used it to multiply my exponent. So remember that I have a product here. I have a multiplication to start with inside my bracket. Okay? I can do that. Same with division. I can do that if I have a division inside of my bracket. So if I have a division inside my bracket, I can still also do the distributive property, and that would be x to the power of 8 divided by y to the power of 6. Okay? So in the case of product and division, or multiplication and division, I can distribute. In the case of subtraction and addition, I cannot. So I have subtraction or addition between my terms, I cannot distribute. Okay? I want to ask you a question. Going back to the quadratic. If you had x minus 1 squared, what did you used to do to be able to expand this?
You would do it again, like write it.
You would write it twice,
Yeah.
and then
And it's
foil, right? So, and then we used to multiply this by this by this, this by this by this, right? So I used to get x squared minus x plus 1, which is x squared minus 2x plus 1. So we have to foil, right? So in the case of subtraction or addition, I can't just distribute, okay? I have to actually write it twice and then foil. Okay? Which is, we learned that prior. So if I want to foil this, this is where you're going to have to use your exponent law. How do I foil this? What do I multiply by first? X to the power of 4 times x to the power of 4. Right? So I have to multiply this by this first. So that's x8 because I'm adding my exponent, right? Good, good. Okay.
Then x4 by y, negative y3.
So what does that give me?
So
So if I multiply this by this, what does that give me?
minus xy
How about the exponent? Where did the exponent go?
to the power of 1.
Nope, because you can't subtract.
Oh, you
They're
can't.
different terms. They're different base. So you just have to leave it as x4 and y cubed. There's nothing you can do about this. Okay? Right? Now, let's keep going. So I'm going to have to multiply now negative y cubed by x to the power of 4. What does that give me? Positive or negative? Let's start with that. Negative.
Negative y3
Mm-hmm.
and x4.
Can I write it x4, y3?
Yep.
So it doesn't matter if you write x4, y3 or y3, x4, right? Because it's multiplication. Okay?
And then
This and this, they're exactly the same thing, right? Again, going back to 2 times 3 or 3 times 2, it's going to give me 6, no matter which way I write it. Okay?
Why didn't you do the y's together?
What, I haven't got into that yet.
Oh.
You mean
okay.
like this one and this one?
Yeah.
Yeah, I haven't got into that yet. Now, negative y cubed minus y cubed, or times negative y cubed.
plus y to the 6th.
So what's that one there?
Which one?
3.
This one?
Yeah.
If I'm multiplying y cubed by x4.
Oh, okay. Then you can't do anything. So you put the 2 terms.
Put it, yeah.
Okay.
Okay? So the last one, negative times negative gives me a positive.
Plus,
And then y cubed times y cubed, that's y 6. So after I do this, now I'm going to collect like terms. Do I have any like terms there?
yep,
Yes.
Where are they?
x, negative x to the 4 and y to the
So I have two of them, right?
3. Yes.
So x8 is going to stay the same. This term and this term, they're like terms. What do I do with them? Add them or subtract, right? So you have negative x4y cubed minus x4y cubed. So that means you have negative 2x4y cubed. Right? I'm going to take you back here for a second. Eyes on me because I know this is confusing for a lot of students. Eyes on me, please. Pencils down. Don't write. When I used to do my multiplication here, right? And I used to get negative x and negative x, right? What's negative x minus x? What's x plus x? 2x. What's negative 1x minus 1x? Negative 2x, right? So I used to take the coefficient, so in this case it is negative 1, and I used to add or subtract the coefficient. So in this case, negative minus 1 is negative 2. Okay? I have the same thing here. I have negative 1 x4y cubed and negative 1 x4y cubed. So that gives me negative 2 x4y cubed. Okay? And then my last term is going to stay as y 6. We will not see a lot of this kind, okay, of expanding right now, okay. Most of it is going to be what you have seen in the product and the division and the quotient. Okay. So I want to go over one more thing before I give you some time to work on this, okay? If I have 3x y4 to the power of 2, how would you simplify that? So you're just multiplying that 2 with the power of 4, that's it?
Yeah. But then the 3 has to be.
Oh, the 2 goes into the 3 as well?
Or the 3 goes into the 4.
No,
Or you want to.
I think you have to multiply.
Oh,
the
stop
three
this,
as
Mike. The 2 goes into the 3 too?
well. No.
It goes to everything inside the bracket.
Really?
Oh, snap. Okay, so.
Everything inside the bracket. So how about this x? Where did this x go? Where's the exponent for, what's the exponent for this x?
Yeah, 1.
1. So I also have to multiply that 2 by the 1. What's the exponent on the 3? 1. So I also have to multiply that 2 by the 1. And this is the most common mistake, is students ignore that beautiful coefficient that we have there, and they don't square it or they don't raise it to the power. Right? Guys, eyes on me, eyes on me. Leave everything, eyes on me. If I'm going to expand this, right? If I'm going to write this, I'm going to write it as 3x y4 times 3x y4, no? Because it's squared, right? So that means it's multiplied by itself twice. If I'm going to come to simplify this, I have 3 times 3, right? I don't ignore that 3. I have to write it twice. Then I have x times x, which is? Then I have y4, which is?
Y to the 8.
Right? So when I come, if I don't want to expand, because let's say if it's to the power of 6, do you really want to write this 6 times and try to multiply 6 times? No, right? You would rather do the distributive, right? When you're distributing the exponent in, you have to distribute it to every single letter inside the bracket. If it helps you, put the exponents, the invisible exponents on. Right? So, here's another one. If I have I'm going to use something other than 3. 4x cubed over y squared all to the power of 2. What do? Put the invisible one on the 4. Okay?
So then that's 4 squared,
4 squared,
x to the power of 6
x to the power of 6 over
y to the power of 4.
yes. So you're distributing that exponent to everything inside the bracket. Are we clear with that? All right. So I'm going to leave you with the questions. The first one is exactly the same as the example that I did with you, so ignore that one if you want, and do the rest. Okay? We're good? And I'll get back to this